3 and 4, basic. Here are Professor Moore's times in minutes to swim 2,000 yards and his pulse rates after swimming in beats per minute for 23 sessions in pool. Then they give you the time rates and the pulse rates. For A, verify that a linear model appropriately models the data and state the equation of the linear model. So you plug in your values into your calculator, into stat, edit, and you do your lists, which I've already done. From there, you get your 4 equations, your linear, power, exponential, and logarithmic, and you look at your r squared values. For your linear, you get 0.556, exponential, you get 5.547, and so on. Because this one is closest to 1, that's the one you use, and you get y equals a plus b ln of x. You plug in the values that your calculator gives you, and you get y equals 1,347.598 plus negative 339.504 ln of x. B. The next day's time is 34 minutes and 30 seconds. Predict the professor's pulse rate. His actual pulse rate was 152. How accurate was your prediction? So for this, you're going to plug in 34 minutes and 30 seconds for your x. When you plug all of this into your calculator, you're going to get y equals 147.402. Because the actual time was 152, you subtract 147.402 and your prediction is 4.97 beats per minute away from the actual. C. Suppose you were only told that the pulse rate was 152. You now want to predict the swimming time. Find the equation of the least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? So this time you want to plug in 152 for your y and you're looking for x. From here you subtract 1,347.598 and you're left with negative 1,195.598 equals negative 339.504 ln of x. You divide and you're left with 3.52 equals ln of x. From here, you know that your base is e, so e to the power of this equals x. When you plug this into the calculator, you get x equals 33.84 beats per minute. To check this, you could plug this back in for your x, and when you get this, you're going to get 152, which is accurate because that's the answer. D. Explain clearly to someone who knows no statistics why there are 2 different regression lines. Well, your linear regression line is more of a guide. For this problem, the logarithmic line is more useful because, as we saw in the first part of the problem, your r squared value is closer to 1.